Good morning everyone. So today again we will continue the numerical of chapter 1 solution. So our first numerical it is determine the elevation of the boiling point of aqueous solution with 1 mole of solute having a density 1.2 gram per milliliter. Okay, 1 mole of solute, it is actually dissolved in 1000 ml of solution. Okay, this is the quantity of solution. Okay, it is the volume. So what will be the answer? Actually answer it is 0.98 kb. Okay, so how we can calculate? First you should know the formula of elevation in boiling point. That is delta TB is equal to kb into m. Okay, it is the molality. And what is molality here? It is the moles of solute divided by mass of solvent. Okay, so here mass of solvent it is not given. So mass of solvent, how we can solve? By subtracting the solvent from solution. By subtracting the solute from solution. Solution minus solute will give solvent. Okay, so mass of solution minus mass of solute, it will give the mass of solvent. So everything it is given here. Moles of solute it is given, density it is given. So mass of solution, how you can solve? As we know, density is equal to mass by volume. You need to solve mass of the solution. So m is equal to d into v. And what is d here? It is 1.2 gram per milliliter into volume. How much volume it is? 1000 ml. Okay, so you can solve the mass of solution. So after calculation you will get 1200 gram, that is equal to 1.2 kilogram. Okay, in kilogram you can get 1.2 kilogram. So mass of solution you have got. So now our next step it is to calculate the mass of solvent. Okay, then mass of solvent, how you can solve? Mass of solution minus mass of solute. Okay, so mass of solution it is given to you, that we have solved already. Okay, it is 1200 gram. Okay, and mass of solute, how you can solve? As we have taken here glucose, then molecular mass of glucose it is 180 gram. So mass of solute, how you can solve? You know the relation between moles and mass. Moles, it is equal to mass by molar mass. And moles, how much given? It is 1. Molar mass it is 180. So 1 into 180 it is equal to 180 only. That is the mass of solute. So mass of solute also you have got 1200 minus 180, it is equal to 1020 gram. Okay, so this is the mass of solvent we have got. Now molality you can solve very easily. Delta TB is equal to kb. Okay, this value also given to you. And molality it is moles of solute, that is given to you 1. Okay, and mass of solvent we have solved. In kilogram it is 1.02. Okay, so after calculation you can solve the elevation in boiling point, that is 0.98 kb. Okay, so now our next question it is, why is osmotic pressure preferable to other colligative properties? Okay, as we know, what is the chemical formula of osmotic pressure? What is the formula? It is represented by pi and it is equal to CRT. What is C here? It is concentration that we have taken in terms of molarity. Okay, so why osmotic pressure it is more better? Because we can easily measure the pressure at room temperature. Okay, that is why at room temperature we can easily measure. One more thing it is there, concentration we have taken in terms of molarity, and molarity it is more better measurement in dilute solution. Okay, in very dilute solution you can measure molarity more easier way as compared to molality. Okay, so that's why osmotic pressure it is preferred as compared to other colligative properties. Now our next question it is, define Kb and factors that influence it. So as we know, delta Tb is equal to Kb into m. Then how you can define Kb? Kb becomes equal to delta Tb. And what is delta Tb? It is elevation in boiling point. If molarity of the solution, it is 1 molar. Okay, so this is the definition. Every constant we are writing like that only, in this form only definition we are writing. Okay, it becomes equal to delta Tb when molarity of the solution, it is 1 molar. Okay, and what are the factors that influence it? So you can see here definition. The molar elevation constant, that is Kb. It is the increase in boiling point, or you can say elevation in boiling point, that is caused by dissolving 1 mole of solute in 1000 gram of the solvent. It means what? How much quantity you have taken? 1 molar. Its other name is ebullioscopic constant. Okay. So molar elevation constant, it depends only upon the solvent. It does not depend upon the solute. So it means you can say for every solvent, the molar elevation constant value will change. Now our next question it is, when SPM is placed between two isotonic solution. SPM means semi-permeable membrane. Okay, so what will happen? Isotonic solution means if you have taken the beaker, inside this you have taken RBC. Okay, suppose it is RBC. Outside RBC you have taken the solution that has the same osmotic pressure as that of RBC. This type of solution it is called isotonic. If inside RBC or outside RBC both are having the same concentration, then they will have the same osmotic pressure. If osmotic pressure will be the same, then there is no net movement of water. Okay, no net movement. I am saying no net. Then we can say na, there will be no osmosis. Okay. So according to option we have to go, osmosis do not occur. Our next question it is hypertonic solution and hypotonic solution. Okay, so you have to define hypertonic and hypotonic. So actually what is the meaning of hypertonic? Hyper means excess concentration. So where you have kept the excess concentration? Outside the cell. Suppose you have taken the beaker, inside that RBC you have taken. If RBC you have taken, so outside this RBC, if you have taken the higher concentration, okay, RBC it is having low concentration, then net flow of water will take place from RBC to outside. Then shrinkage will take place. So you can say na, in hypertonic solution shrinkage will take place. In hypertonic, it is the opposite case of hypertonic. In the hypertonic solution we are having less concentration than RBC. Okay, this is the beaker, inside that RBC I have taken. Here it is less concentration. Then where water will flow, it will flow from outside to inside. Okay, then swelling will take place, collapsing will be there. Okay, then RBC will collapse. Okay, so this type of solution we can say it is hypotonic. In hypertonic shrinkage, in hypotonic swelling will take place, collapsing will take place. So our next question it is, which colligative property is used for the determination of molar masses of biomolecules? So which concentration, which colligative property will prefer? That is osmotic pressure. Already we have done osmotic pressure. It is very easier method to measure at room temperature. Okay, so reason also it is given. So our next question it is, in 1 liter glacial acetic acid, 0.1 molar acetamide is dissolved. Okay, how much quantity of glacial we have taken? Glacial, actually it is the having chemical formula CH3COOH. Okay, in that what we have added 0.1 molar acetamide. When the solution is cooled, the molecule contains the first crystal that forms at the freezing point. Okay, so that crystal formed at freezing point, that you have to tell. Okay, so crystal formation of which it will take place? It will take place of glacial, and that is the having chemical formula acetic acid. Okay, so why we are having this option glacial? because it act as a solvent. Okay, so only solvent molecules solidify at the freezing point in the depression of freezing point experiment. Okay, because the solvent molecule in this case is acetic acid, that's why first crystals of solvent means we have taken here glacial, it will take place. Okay, so during depression in freezing point, or you can say during for the calculation of freezing point, first freezing of solvent will take place. Our next question it is, which of the following statement are correct for depression in freezing point? Okay, so first option it is given here, solution has lower vapor pressure than pure water. Definitely. Okay, pure water it will evaporate more easily as compared to impure, so solution height is having a lower vapor pressure. Okay, so it is correct. Solution has higher vapor pressure, definitely it is wrong, because first option it is correct. Okay, at the freezing point only solvent molecules solidify, we have done in earlier question also. At the freezing point only solute molecule, it will not, means it will take the time. So first which one will solidify? Solvent. Okay, then fourth option it is incorrect. So which one is correct? First and third option.